You've probably been there, right? You ask an AI a seemingly simple question, and you get a bizarrely wrong answer. It has all the facts, it knows all the data, but it just can't seem to connect the dots. It's a huge problem, actually. But what if I told you new research is uncovering a really strange phenomenon where these AI models suddenly just wake up? They literally teach themselves to reason. Today, we're diving into the fascinating world of grokking.
All right, let's get into it. First, we're going to lay out the mystery of this AI reasoning gap. Then we'll look at our main clue, this whole grokking phenomenon. From there, we'll peek inside the AI's brain to see what's actually going on, uncover a tale of two competing circuits, and finally see the absolutely incredible payoff when this all comes together.
So let's kick things off with the central mystery. We have these unbelievably powerful models, think GPT-4, and yet they stumble on logic that, a child could probably figure out. And this isn't just some minor quirk, it really points to a fundamental gap in how they think.
This really is the core question, isn't it? We've all seen this happen. You feed an AI two perfectly good pieces of information, and it just can't make that logical leap to a third. It's super frustrating, and honestly, it holds back the true potential of these systems. So what is going on here?
This is a perfect example of what researchers call the compositionality gap. The AI knows fact A, Barack's wife is Michelle. No problem. It also knows fact B, Michelle was born in 1964. Easy. But it can't combine them to get to the super simple conclusion that Barack's wife was born in 1964. It's like having all the ingredients for a cake laid out on the counter, but being totally unable to follow the recipe. This isn't a small thing. It fundamentally limits an AI's ability to truly generalize its knowledge.
So, how in the world do we solve this mystery? Well, the first big clue comes from a really bizarre behavior that researchers started noticing, a phenomenon they decided to call grokking.
The word grok actually comes from science fiction, and it means to understand something completely intuitively. And that is exactly what's happening here. So an AI model will be training on data, and it'll get a perfect score on its memorization test, and then nothing. But if you just keep training it, long past the point where it seems to be learning anything new, something just clicks. It suddenly groks the underlying rules.
You can literally see it happening right here on this graph. I mean, look at this. For thousands and thousands of training steps, the model's accuracy on brand new problems, that's the test data, is just flat. It's near zero. It's just memorizing stuff it's already seen. Then, all of a sudden, boom, the accuracy shoots straight up to nearly 100%. That vertical line isn't a mistake. That is the AI having its aha moment.
So here's the crucial discovery. This isn't about just throwing more and more data at the problem. Nope. The researchers found that what actually triggers grokking is the distribution of the data. To be specific, it's the ratio of simple atomic facts to the more complex inferred facts that require reasoning. Getting that mix just right is the key to pushing the model from simply memorizing to genuinely understanding.
Okay, so we've seen what grokking is, but the really mind-blowing part is understanding why it happens. And for that, we need to go inside the model itself and see what's actually changing during all that extra training time.
Think of it like the AI is developing two different brain pathways to solve a problem. The first one it builds is the memorizing circuit. This is the quick and dirty shortcut. It's like a giant lookup table, just linking questions directly to answers. It works for the training data, sure, but it's not flexible. At the exact same time, though, it's slowly, patiently building a second pathway, the generalizing circuit. This one is way more complex. It's actually learning the rules behind the data.
And this explains why that aha moment happens so late in the game. You see, during training, there's this process called weight decay, and you can think of it like a tax on complexity. It's constantly pushing the AI to find the simplest, most efficient solution. Now, at first, memorizing is easy, but as that list of memorized facts gets huge and clunky, that tax gets higher and higher. Eventually, it becomes less costly for the AI to just finish building the elegant, efficient reasoning circuit. It takes the smarter path, and that's the moment we see grokking.
Now let's move on, because this is where it gets even more interesting. It turns out the AI doesn't just build one type of reasoning circuit. The kind of problem you ask it to solve actually changes the kind of circuit it creates.
So the researchers tested the AI on two totally different kinds of reasoning. First was composition, which is that Barack's wife's birthday problem we talked about. You have to find fact one, then use that to find fact two. It's a sequence. But the second task, comparison, is different. To figure out if Barack is older than Michelle, you have to look at both of their birthdays at the exact same time. And check this out. This is what the AI built. For the composition task, it created a serial circuit, just like an assembly line where information gets processed one step after another. But for the comparison task, it built a parallel circuit designed to look at both pieces of information simultaneously. The AI literally built a different brain structure depending on the logic it needed to use. Wild.
And this structural difference has massive consequences. That serial circuit, it stores the knowledge for step 1 in a completely different part of the model than the knowledge for step 2, so it can't really generalize to new combinations it's never seen before. The parallel circuit, on the other hand, stores all of its knowledge in a shared, easily accessible area, and that allows it to mix and match facts on the fly, letting it generalize to totally new data.
So all this brings us to the payoff. Why does any of this really matter? Well, what happens when you put a small transformer model that is truly grokked a problem up against the biggest, baddest AI models in the world? This is where we see the true power of this deeply integrated, or parametric, memory. So the researchers designed this incredibly difficult reasoning puzzle. To get the answer, the AI would have to navigate a huge search space of facts, connecting multiple different ideas to form a logical proof. There were absolutely no shortcuts. This was a pure test of reasoning.
The results are, well, they're just stunning. GPT-4 Turbo was essentially just guessing, getting it right about a third of the time. Gemini 1.5 Pro did a little better, but not by much. But the small, specialized transformer that had been trained until it grokked the reasoning circuits, it hit 99.3% accuracy. It didn't just outperform the giants, it solved a problem they couldn't even begin to tackle.
And get this, here's the real kicker. When the researchers asked Gemini to show its work, over 70% of the time, it just gave up. It literally said the answer could not be found, even when all the facts were right there in the data it was given. The system was just overwhelmed by a level of complexity that the smaller, grokked model handled like it was nothing.
So the huge takeaway here is this. The big models, they were using what's called non-parametric memory. It's like having access to a giant library, but not knowing how any of the books are connected. And they failed. The small grokked model used parametric memory. It didn't just have the library, it had read all the books and internalized the rules into its own structure. For really complex reasoning, that deep integrated understanding, it's not just an option, it's a necessity.
This research really opens up a profound new possibility. We're not just teaching AI to memorize facts anymore, we're actually creating the conditions for it to teach itself how to think. And that forces us to ask a really thrilling and maybe even a little unsettling question. If AI can teach itself to reason, what on earth will it discover next?
This is for entertainment purposes only.